Welcome back. This is Mrs. RRubright with Advanced Geometry. Today's notes are on 8.3, show that a quadrilateral is a parallelogram. We started by copying the notes from the book on pages 516, 517, and 519. So let's get into our first example. An amusement park ride has a moving platform attached to 4 swinging arms. The platform swings back and forth higher and higher until it goes over the top and around in a circular motion. In the diagram below, segment AD and segment BC represent 2 of the swinging arms, and segment DC is parallel to the ground. Line L. Explain why the moving platform AB is always parallel to the ground. So it said that DC is parallel to the ground. So what do we know? What do we know? I bet it's something that you guys copied down. These are both 16 feet, so they're congruent. These are both 38 feet, so they're congruent. It's a parallelogram, is what you're saying? So if this is parallel to the ground, then this is parallel to the ground? So the shape of the quadrilateral changes as the moving platform swings around, but the side lengths do not change. Both pairs of opposite sides are congruent. So if you have both pairs of opposite sides congruent, then by definition it is a parallelogram. That is theorem 8.7. So both sets of congruent sides makes it a parallelogram 8.7, theorem 8.7. By the definition of a parallelogram, AB is parallel to DC, so DC is parallel to line L, and AB is also parallel to line L by the transitive property of parallel lines. So the moving platform is parallel to the ground. In the quadrilateral WXYZ, the measure of angle W is 42, the measure of angle X is 138, Y is 42. Find Z. Is this a parallelogram? Explain your reasoning. All right, so the first thing we're going to do is actually draw this parallelogram. W, X, Y, Z. W is 42 degrees. X is 138 degrees. Can someone lock my door, please? Y is 42 degrees. And Z we are trying to find out. This is a 4-sided object. It is a quadrilateral. 4 minus 2 is 2. 2 times 180 is 360. So all these angles must add to 360. 360 minus 42 minus 138 minus 42 leaves me with 138. Now, because opposite angles are congruent, it is a parallelogram. So if opposite sides are congruent, it's a parallelogram. If opposite angles are congruent, it's a parallelogram. So since the sum of the interior angles of the quadrilateral is 360, it leaves Z as 138. Now that opposite angles of the quadrilateral are congruent, it must be a parallelogram. The doorway shown is part of the building in England. Over time, the building has leaned sideways. Explain how you know that SV equals TU. How do you know that SV equals TU? So we have another rule for parallelograms. The next rule is if you have congruent parallel sides, right, since these are congruent and parallel, what do we know? Well, this would be a transversal now. If these are parallel, isn't that a transversal? A line cutting through 2 parallel lines. So whatever this angle is here is going to be the same as here. So basically, these 2 are consecutive interior angles. Right here and here are consecutive interiors. So this angle plus this angle equals 180, right? Same thing here. But look, well, wait, they didn't say that those 2 are parallel. Explain how you know that they are equal. So how do you guys know? You read a bunch of stuff. What did you read? How do you know that this and this are equal? We know that they're parallel and congruent. Yes. Which theorem is that? So by theorem 8.9. So she said in the paragraph, okay, so this says that because they are parallel and congruent, theorem 8.9 says the quadrilateral is a parallelogram. So because they're parallel and congruent, it's theorem 8.9 that says, hey, I'm a parallelogram. Now that it's a parallelogram, these are also parallel and congruent. By theorem 8.3, you know that opposite sides of a parallelogram are congruent. For what value of x is the quadrilateral a parallelogram? So if it's a parallelogram, what do we know about its diagonals? They are bisected. Set these equal to each other and solve. So if I subtract 5x from both sides, I would have negative 8 equals negative 2x. Divide by negative 2 on both sides. And I would get that x equals positive 4. So by theorem 8.10, if the diagonals bisect each other, then it's a parallelogram. When x is 4, you're going to get that Fn is 12 and Dn is 12. The quadrilateral is a parallelogram when x is 4. What theorem can you use to show that the quadrilateral is a parallelogram? So they are congruent and parallel. We just did this one, right? One pair of congruent and parallel opposite sides, right? Which theorem was that? You just said it. 8.9, good job. So you have to have these memorized. How about this one? What theorem can you use to show that the quadrilateral is a parallelogram? We have opposite sides are equal. Two sets of opposite sides are equal. Which one is that? 8 point what? 8.7, good. Opposite angles are equal. Which theorem is this? Opposite angles are equal, therefore it's a parallelogram. Which theorem? Good job, 8.8. For what value of x is the quadrilateral a parallelogram? So this one would be diagonals bisect each other. They are going to be congruent. So 2x equals 10 minus 3x. Add 3x to both sides. 5x equals 10. So x equals 2. Divide by 5 on both sides. X is 2. The diagonals of a parallelogram bisect each other. So once you solve, you get x is 2. Show that the quadrilateral ABCD is a parallelogram. So you can use any of these theorems that we already went over. So why not? Let's check out their slopes. So we have rise 1, 2, run 1, 2, 3, 4, 5. Slope of 2/5. Rise 1, 2, 1, 2, 3, 4, 5. Slope of 2/5. So we know that these are definitely parallel. Down 1, 2, 3, over 1, 2, 3. So that's down 1 over 1, down 1 over 1, down 1 over 1. Slope of negative 1. Down 1 over 1, down 1 over 1, down 1 over 1. Slope of negative 1. So we definitely have two sets of parallel sides. If we have two sets of parallel sides, is it automatically a parallelogram? Yes or no? A, B, and CD are congruent and parallel. So ABCD is a parallelogram by theorem 8.9. So you could have done one side, proved that it's parallel and congruent. How would I prove that it's congruent? So I have that these two are parallel, and then to know that they're congruent, if we're going up 2 over 5, you could do a nice little Pythagorean theorem here. 2 squared is 4, 5 squared is 25, so that's 29. So this is the square root of 29, right? A squared plus B squared equals C squared. We have 5 and 2 here also. So we're going to get the same square root of 29. So they are congruent and parallel. Refer to the concept summary. Explain how other methods can be used to show that the quadrilateral in example 4 is a parallelogram. Explain how other methods can be used. The quadrilateral in example 4. Which one are they referring to? I guess this one. So what else could you have used? So one set of parallel and congruent sides. You could have done what? 4 pairs of congruent sides, like both sets of opposite sides being congruent. Anything else? Find the slopes of all 4 sides and show that the opposites are parallel. That's the first thing we did, right? The second way is to find the lengths of each side and show that opposite sides are congruent. We said that one too. The third way would be to do the diagonals and show that the diagonals bisect each other. And that was everything from our lesson today on 8.3, show that a quadrilateral is a parallelogram. I hope you enjoyed the lesson. Stay tuned to our channel for our lesson on 8.4. Subscribe if you like us.